Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, Tifr, Jest, IIT-Jam exam and other exams related to physical science. Okay, and also guys, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes which are going to help you to crack the exams related to physical science. So this is the seventh part of this series of CSIR NET Physics PYQ of June 2017, sorry, to June 2019. Okay, so this is the seventh part of this series in which I'm going to discuss, or we are going to study part C questions, and those questions are of 5 marks. Okay, so I'm going to start now. I'll start with first question. The first question is, so these are part C questions guys, okay? Very important questions and you need to practice these questions and revise. So the first question is, this question is from Archimedes principle, okay? So question is, a solid cock, a solid cock solid spherical, okay? Spherical, solid spherical cock of radius r, of radius r and specific gravity, and specific gravity, specific gravity 0.5, 0.5, floats on the water, floats on the water, floats on the water, the cork, the cork is pushed down, pushed down so that its center of mass, its center of mass is at a distance, is at a distance, is at a distance h, okay, where h is between 0 to r. Below the surface of water, below the surface of water, surface of water, and then released, and then released okay, Meanwhile, just let me check am I audible or not. The cork is, yes, I'm audible. Okay. The volume of the volume of the part of the cork volume of the part of the cork part of the cork above the water level above the water level is pi r cube into 2 by 3 minus cos theta 0 plus 1 by 3 cos cube theta 0, where theta 0 is the angle as shown in the figure as shown in the figure I will draw the figure as well. Okay. So figure, I'm drawing the figure. Okay, I'm just drawing it. There is some issue, guys. Technical issue. Just give me 1 minute, okay? So there's a technical issue. So I'm writing question again, right? Okay, because that was gone. Okay, so there is some issue, and I really apologize for the inconvenience. Okay, so I'm writing it again. So this is a solid spherical cork of of radius r, and and specific specific gravity 0.5 floats on the water, floats on the water. The cork is the cork is pushed pushed down so that its center of mass at a distance h at a distance h, where h is between 0 to uh, r below the surface of water, below the surface of water, then released and then released. The volume the volume of the volume of the part of the cork part of the cork above water level above water level is pi r cube pi r cube 2 by 3 minus cos theta 0 plus 1 by 3 cos cube theta 0, where theta 0 theta naught is is the angle is the angle as shown in the figure, as shown in the figure, shown in the figure. Here I'm going to draw the figure. Okay, so I'm just drawing the figure. Okay, so this is the figure, guys. Okay, so this height is h. Okay, this height is h. This angle is theta naught. Okay, and this is r, and this is water level. Water level. Okay, this is the figure which is given, right? Okay, this is next point is at the moment of release. At the moment of release, at the moment of release, the dependence of the upward force, the dependent of upward force upward force on the cock on H, on the cock on H is options are given. Option number A is H by 3, H by R minus 1 upon 3 H upon R cube, H upon R cube option B is h upon r plus 1 by 3 h upon r cube. Option C is h by r minus 2 by 3 h upon r cube. And option D is h by r plus 2 by 3 h upon r cube. Okay, so this is the question. Very good question, guys. And this question is based on Archimedes principle. Okay, so a solid spherical cork. Okay, this is spherical cork of radius r and specific gravity of that is also given 0.5 that floats on the water. Okay, that floats on the water. The cork is pushed down so that its center of mass at a distance h below the surface of water. Okay, so we have pushed this into the water. Okay, so this is pushed like till this height. Okay, this is the line of center of mass of the cork. Okay, so we have pushed down this, and this is the water level, and this height till this height h. Okay, and then the volume of the part of the cork above the water level. Okay, and then we released it, and the volume of the part of the cork above the water level, and the volume of, we have been given the volume of the cork, the part of the cork which is above the water level. Okay, this is given, right? Pi r cube into 2 by 3 minus cos theta naught plus 1 by 3 cos theta naught cube, where theta naught is the angle as shown in the figure. So this is the angle given. Okay, theta naught. Okay, and what we need to find out, we need to find out at the moment of release, when we release it. Okay, that time the dependent, that time the dependence, it is dependence, guys. Okay, the dependence of upward force on the cork on h is, okay, the dependent of upward force on h. So we need to find out force. Okay, dependence of force on dependent of force, upward force on the cork on h. Okay, so we need to find out the dependence of force, okay, on h, how that that forces depends on h. Okay, how that force is function of h, that's what we need to find. Okay, so I will solve now. So first what we are going to do is, first we'll find volume of the cork. Okay, so volume, very good question, guys. Okay, volume of cork, is, we know that is a radius is given, that is 4 pi r cube, right? Radius is given and the volume of, because it's a spherical, that's why this is 4 pi r cube, right? Now we'll find the weight of the cork. Okay, weight, which is spherical. Okay, weight of the cork, weight of the cork. Okay, so weight of the cork is going to be this one. Weight of the cork, right? We have a volume, and then weight. Weight means what we do. We will multiply volume with g, right? The gravity, and also there is a specific gravity is also given. So this is going to be 4 by 3 pi r cube, that is volume into specific gravity 0.5 into g, that is gravity. Okay, so this is going to be, if we solve it, this is going to be 2 pi r cube g by 3. Okay, 2 by 3 2 pi by 3 r cube g. okay, which would be in downward direction. Okay, this direction will be downward. Okay. Okay. I hope you understood, guys. Okay. Next, so this will be downward. Okay. Now we will find because we are going to use Archimedes principle here, right? So we need to find first, that is volume of liquid displaced by cork. Okay. So volume of volume of liquid volume of liquid displaced displaced by displaced by cork. Okay, displaced by cork, that is going to be, 4 pi, that is total volume of that sphere or that cork, that is 4 pi by 3 4 pi r cube minus the volume of the part of the cork which is above the level water level surface. Okay, above the level of water surface. Okay, so that is good, that is given here, this one, right? So this would be 4 pi r cube minus pi r cube 2 by 3 minus cos theta naught plus 1 by 3 cos cube theta naught Okay, right? We'll simplify it. So it is going to be 4 by 3 pi r cube minus 2 pi r cube upon 3, will multiply it, right? Minus minus plus pi r cube cos theta naught, then minus 1 by 3 pi r cube cos cube theta naught, right? So from this figure we can see, right? From this figure we can see this is theta, this is r, right? And this height is h, this one. So from here we can easily find cos theta naught is going to be equal to h upon r, right? This is base, this is hypotenuse, right? So cos theta equal to base upon hypotenuse, right? So cos theta's value is going to be this one, h upon r. Okay, so here cos theta, you can write, since cos theta equal to h upon r, right? So this is going to be, we'll put the value of this will get cancelled, so 4 pi r cube, and this is going to be 2 pi r cube upon 3. We have subtracted 2 pi r cube from 4 pi r cube by 3. Okay, 2 pi r cube by 3 we subtracted from 4 by 3 pi r cube. So this is 2 pi r cube by 3, and this is pi r cube, we can take common here. Cos theta naught value is h upon r, right? From geometry we have found. Okay, and minus 1 by 3 h upon r whole cube. Okay, cos cube is h upon r whole cube. So this is the liquid volume of liquid displaced by cork when we immerse that cork, push down that cork inside the water, right? That time the water displaced by the cork is that volume is this one. Okay, next. Next is, so now we have got volume, right? We have got volume, the displaced volume, right? We can also note this by V1, okay? V1. So now we will find the weight of displaced liquid, okay? So weight of the displaced liquid is going to be weight of displaced liquid. Weight of displaced liquid is going to be, we know this, there is a formula, that is V1 dg, or we can write V1 rho g, right? Rho is density of water, okay? So this is going to be, that weight is going to be and d is 1 for that 1, okay? The value of d is 1, that is the density of water is 1, okay? That 1 gram per centimeter cube, right? So this is going to be the value we will put it, okay? So VDG, and from the Archimedes principle we know that that uh, that that is going to be equal to buoyancy force, okay? The buoyant force, okay? We know what is buoyant force, that the force exerted on the object which is immersed, right? The force immersed in water or any liquid, force exerted on the object, right? uh, that is going to be equal to the water displaced by the object, the weight of water displaced by the object, right? So this is going to this is the FB according to Archimedes principle, okay? So this is we can write buoyant force, okay? Buoyant force, FB, right? So this is going to be, because this is equal to this, right? I can write like this, D is 1 here, okay? So this is going to be FB, okay? Buoyant force, and then this means the buoyant force is going to be, FB is going to be weight of displaced liquid, right? So V1 dg, so d is 1, since d is 1, okay? Density of water is 1, so it is going to be V1. The value of V1 I have already found, this 2 pi, this is going to be 2 pi r cube, 2 pi r cube 2 pi r cube upon 3 g, right? G is also here, plus pi r cube from here, right? This one, this we have multiplied this by g, okay? So 2 pi r cube by 3 g into pi r cube g, and this term, okay? Pi r cube g, and this term, this is h upon r minus 1 by 3 h upon r cube, h upon r whole cube, okay? This is the one, okay? So now this is the buoyant force, okay? Yeah, buoyancy force we can also say, buoyant force. And now we will find upward force, okay? That's what is asked in question, okay? So this one, the dependence of upward force on the cork, okay? So this is going to be upward force, that this is going to be upward force is going to be upward force, or we can write it by delta F. This is going to be buoyant force minus Fw, that is the force because of the cork, right? This one, the weight of the cork, this one, this one, the weight of the cork. This is denoted by the weight of the cork. Okay, this would be downward, right? And we can write that as a Fw. Okay, so buoyance so the upward force is going to be buoyant force minus the force exerted by the cork, right? So this is now what we will do. This is 2 pi, will subtract it, right? 2 pi r cube upon 3g plus pi r cube g h upon r minus 1 by 3 h upon r cube minus this Fw. Okay, the value of Fw is this one, 2 pi r cube g by 3, right? 2 pi r cube g by 3. This, then this will get cancelled, and this is going to be delta F is going to be pi r cube g into h upon r minus 1 by 3 h upon r cube. Okay, this one. So this is the upward force. Okay, so what we have, what is asked in question? In question, it is asked the moment at the moment of release, the dependence of upward force on the cork, on H. How this force is dependence on H, right? So so this is the one, or we can write delta F is dependent on, that is delta F is proportional to this is constant, right? This one we can use proportional to pi r cube g. Sorry, this is going to be h upon r minus 1 by 3 h upon r cube whole cube, right? Okay, so this is the answer. So which option is matching? We'll check it. Okay, this is the answer. So which option is matching? Option number A is matching, right? H upon r cube minus 1 by 3 h upon r whole cube. Okay, so very good question, guys. I would request you revise this question and practice it. Okay, and this question is based on Archimedes principle. Next question, guys. Next question. This is also very good question, guys, and this is the question from classical mechanics. Okay, question is question number 2. Question number 2 is two particles of mass m1 and m2. Two particles of mass m1 and m2 are connected by a massless thread, a massless thread of length L, as shown in the figure, below. Okay, I'll draw the figure in next page. So this one. Okay, This is M1 mass M1, okay, and this is straight line, guys, okay. This is mass M2, okay, G is downward, okay, and this particle is like this, moving in circular path, okay. So the particle of mass M, the particle of mass M on the plane, this is on the plane, right? M on the plane, undergoes a circular motion, okay, undergoes a circular motion with radius r naught, with radius r naught and angular momentum L, when small radial displacement, when small radial displacement, when small radius displacement, that is epsilon, is less equal to r naught, okay, where epsilon is less not equal to r naught, is applied, 'its radial coordinate is found to its radial coordinate is found to oscillate to oscillate about r naught, the frequency of oscillation is the frequency of oscillation is, okay. Options are, these are 5 marks question, guys, part C questions, okay. Options are number A, 7m2g upon m1 plus m2, m1 plus m2 by 2, r naught. Option B is root 7m2g upon m1 plus m2 r naught. Option C is root 3m2 g upon m1 plus m2 by 2 r naught, okay. And option D is root 3m2 3m2g upon m1 plus m2 r naught. Okay, this is the question, guys. A very good question. I will read it for you. So this is two particles of mass m1 and m2. Two particles of mass m1 and m1 and m2 are connected by a massless thread of length L as shown in the figure. Okay, as shown in the figure below. So this is the figure, right, guys? This is the plane. These are straight line, guys. Okay, these are not looking straight line, but these are actually straight line, guys. Okay, consider these lines are straight line. Okay, so this is the plane. This is the this particle m1 and this particle of mass m2 are connected by thread whose length is L. Okay, so they are connected like that. So this is a plane, this is on the plane, and this is below the plane. Okay, like that. And particle of mass m, this one, mass m1, actually mass m1 on the plane undergoes circular motion. Okay, so this particle goes circular motion with radius r naught. Okay, this radius is r naught, and angular momentum r naught and angular momentum L. So it's this particles which is moving in circular orbit whose angular momentum is L, that is given. When small radial displacement, that is epsilon, which is less equal to r naught, is applied to its radial coordinate. Okay, when it's applied, its radial coordinate. Okay, its radial coordinate is found to oscillate about r naught. Okay, so the radial coordinate of this is found that is oscillating about r naught. Okay, so the frequency of oscillation we have to found. Okay, we have to find, and these are the options given. Okay, so I'm going to solve it now in next page. Okay, okay, so first we will find Lagrangian. Okay, Lagrangian of this system. Okay, Lagrangian of this system, that is L. Okay, this is like this. Again, I'm going to make a Lagrangian of the system. Okay, this is a plane. Okay, this is mass m2, this is mass m1, which is moving in circular path anti-clockwise. Okay, this distance is r naught, and this is center, and this these two masses m1 and m2 are connected by massless thread. Okay, this is what given. Okay, so Lagrangian is going to be m1 plus m2 half m1 plus m2 r dot square, right? We know it. This is kinetic energy, right? R dot square minus, this is going to be, this is this particle is moving in circular path, so it is half m half m1 uh, r square and theta dot square. Okay, half m r square theta dot. So for this is going to be this potential energy, and for this m2 particle, this is in downward, right? We are taking coordinate from here, so it is going to be minus m2g L minus r, where L is the total length, right? So this is the Lagrangian, guys. Now we have got the Lagrangian, we have made a Lagrangian for it, right? So now we will write Lagrangian equation. Okay, equation of Lagrangian or Lagrangian equation of motion. Okay, Lagrangian Lagrangian equation of motion. Okay, so this is d upon dt, Lagrangian equation we know, right? D upon dt del L upon del R dot minus del L upon del R equal to 0. That is the Lagrangian equation of motion. So we'll put this value and then differentiate. So this is going to be right. First we'll differentiate this with respect to R dot, right? So this is going to be 2 R dot m1 m2 upon 2. R2 will get cancelled, right? And this is going to be m1 plus m2 R double dot, right? Minus this with respect to R, right? So this one is going to be R 2R m1 theta dot square by 2, right? 2 will get cancelled, so it is going to be m1 R theta dot square, right? And this is if you open it, so mgr is a constant, so that value is going to be 0, and because we are going to differentiate it with respect to R, right? So this is going to be m2g, and minus is going to be plus m2g. Okay, this we can say equation number 1. Okay. So now, so this is for this, it's in circular motion, right? Then potential energy is going to this. Okay, so this is the Lagrangian, and this is the equation of Lagrangian, and after that you've got the value this. Okay, next is, since we know the angular momentum is L, right? It means angular momentum L is conserved, right? Angular momentum is conserved because this is given, that is constant is given, right? L is given, right? So since angular momentum is conserved, so we can write angular momentum in terms of angular momentum is mvr or m1 or mr omega square, right? So sorry, or mr square omega, right? So this is m r square theta dot, right? Mr square theta dot is going to be, because it is conserved, right? It is given theta naught theta dot, right? Theta dot. This is conserved, so this is given, right? Because it's conserved, right? And is conserved, so m1 r is given r naught square, and this is theta naught dot. Okay, this will be equal to this because L is conserved. Okay, from here we can find the value of theta dot. Okay, theta dot is going to be r naught square theta naught dot, the m1 will get cancelled. Okay, theta naught dot. Okay, theta naught dot, this one, upon r square, r will come, right? This one, this is the theta dot value. And for circular motion, for this is one, and the second condition is for circular motion, for this to remain in circular motion, this centripetal force must be equal to this the weight of this the weight of m2, right? Or the force on m2, right? So this is going to be for circular motion, and we know circular motion centripetal force in terms of theta dot, right? So this is mr theta naught square, right? mr theta naught square, because this is moving in circular path of radius r naught, right? mr theta naught dot, yeah, theta naught dot square is going to be equal to mg, m2g, right? Because this is moving, and this force is because of centripetal force, and that centripetal force is balanced by mg2 m2g, right? This force, okay, force on m2, right? So this is going to be m2g, okay. So from here we can find the value of, okay, from here we can find the value of theta naught dot square theta naught dot square is going to be, this is m1, guys, okay, first particle. So this is going to be m2 upon m1 r g, right? So this is equation 3 and this is equation 4. So from equation 3 and 4 we can find value of r theta dot square, okay, r theta dot square, because from here you can see this is the theta dot value, and here what we are going to do is we are putting theta dot value from here, okay, right? So theta square will do theta square because we need theta square value, theta dot square value, right? So theta dot square, and from here we'll square it. This is going to be theta dot square, this will be square, and here we'll put the value of theta naught dot square from here, and we get this value. This value is going to be m1 m2 upon m1 r naught cube upon r cube g, that is the value, okay. So from equation 1, that is, we will put the value of r theta dot square, okay. So then equation is going to be from 1, putting the value of this, you can say 1, equation 2 3, or you can say this is 4, or you can say putting the value of r theta dot in equation 1, okay. So putting value of r theta dot square in 1, we are going to get m1 plus m2 r double dot this one, right, r double dot minus m1, and we'll put this value, this is going to be m2 upon m1 r naught cube upon r cube g, okay, plus m2g, okay. So this equation is going to be m1 plus m2 r double dot, m1 will get cancelled, so this is going to be minus m2 r naught cube g upon r cube plus m2g, okay. This is the equation. Now because in question, right, we can see when a small radial displacement epsilon is applied, okay. So here we can write r, because we have small radial displacement is applied, right? So this is r equal to, we can write r naught plus epsilon, right? So in this equation is, you can see, what is the number of equation? Let me check. 4 5, okay, you can say 5, okay. Putting r equal to r naught this in 5, okay. So r equal to r naught, this implies r double dot is going to be epsilon double dot, right? So we'll put this value because this is constant, right? If we differentiate 2 times, this is also going to be differentiated by 2 times, right? So the epsilon double dot. Okay, so now we'll put value in 5. So this is going to be m1 plus m2 epsilon double dot. Okay, epsilon double dot, and then minus this one m2 r naught cube g. Okay, upon r, right? This r, in place of r cube we will write r naught plus epsilon whole cube. Okay, plus m2g plus m2g. We'll simplify it, equal to 0, right? This is equal to 0. This is equal to 0. Okay, so this is going to be m1 plus m2 epsilon double dot minus this will take on up. Okay, so in numerator, so this is m2 r naught g into r naught plus epsilon to the power minus 3 plus m2 g equal to 0. Okay, so then it is going to be m2 plus m1 plus m2 epsilon double dot minus m2 r naught cube g, and here we can take r naught minus 3 common. Okay, so this is going to be 1 plus epsilon upon r naught. R naught is very greater than epsilon, right? Minus 3 plus m2g equal to 0. R naught minus 2 we have taken common, this will get cancelled, so this is going to be m1 plus m2 epsilon double dot minus, this will get cancelled, so this is going to be m2g. This we will open, right? So this is going only to build for 2 terms. So 1 minus 3 epsilon upon r naught plus m2g equal to 0. So m2g is going to be cancelled. So this is going to be m1 plus m2 epsilon double dot minus m2g will multiply, right? Minus minus plus 3 m2g epsilon upon r naught equal to, sorry, my apology, so plus m2g plus m2g is 0. Okay, so this will get cancelled, then the equation is going to be m1 plus m2 epsilon double dot minus, this is going to minus on plus 3 m2g upon r naught epsilon equal to 0. Okay, okay, so now from here we can easily found this implies that is frequency of oscillation, that is omega. Omega is going to be very simple, this one 3m2g, okay, upon r naught into m1 plus m2. Okay, this one, so omega is, this is the answer, guys. Okay, so omega is root 3m2g upon r naught into m1 plus m2. Okay, if this is in this form, then we can directly find omega. Okay, coefficient of this upon coefficient of this. Okay, so 3 m2g upon r naught m1 plus m2. Which option is matching? Let me check. Option D is matching, right? Option D is right. Okay, so this is the one, this is the question, right? This is the answer. 3m2g upon r naught m1 plus m2. Okay, next question, guys. Question number 3. Question number 3 is this is also a good question. Okay, the time evolution of the time evolution of time evolution of a coordinate time evolution of coordinate x of a particle is described by the time evolution of a coordinate x. Okay, coordinate x of a particle is described by described by described by the equation d2 sorry d4x upon d4x upon dt square dt4 dt to the power 4 del 4 upon d4 upon dt4x plus 2 omega square d square x upon d square plus omega to the power 4 minus a4 x equal to 0. Okay, so this is the time evolution of the coordinate x of particle is described. Okay, for omega greater equal to a, the particle will, okay, the particle will options are eventually come to rest at origin. Option A, eventually comes to rest at the origin at the origin. Option B is eventually drift to infinity. Eventually drift to eventually drift to infinity. Eventually drift to infinity, that is mod x tends to infinity. Okay, option C, oscillates about the origin and option D is eventually come to rest. Eventually come to rest come to rest at omega upon a or minus omega upon a. Okay. So this is the question. The time evolution of coordinate x. Time evolution of coordinate x of particle is described by this. Okay. For omega greater equal to a, the particle will. These are the options. Eventually come to at rest. Eventually comes to rest at origin, or eventually drift to infinity, or oscillates about the origin, or eventually comes to rest at omega by a or minus omega by a. Okay. So this is the question. Very good question. So we'll solve it now. Okay. So first, that time evolution equation is given, right? So this is, I will write it. So this is d4 x upon dx square plus 2 omega square d square x upon dt square plus omega to the power 4 minus a to the power 4. Okay, x equal to 0. Okay, that is the time evolution of coordinate x of particle. Okay, and is the q is omega is greater than a. Okay, so this is one. So for solving this type of question, right, what we can do is we can say we can consider let x equal to e to the power kt. Okay, e to the power kt. Okay, so now what we are going to do, we will put e to the power kt here. Okay, so if you put e to the power kt here, so it is going to be so we will differentiate it 4 times, right? So this is going to give e to the power 4 and e to the power kt, right? E to the power 4, e to the power kt plus this is 2 omega square. This is k to the power 4. This 2 times means k square. Okay, e to the power kt. Okay, plus omega to the power 4 minus a4, and this is e to the power kt, right? So e to the power kt is common. We'll take in right hand side, so it is going to be we'll remove that ed, right? E to the power kt is going to will go in right hand side and will become 0, right? Because e to the power kt is not 0. Okay, so this is going to be k4 plus 2 omega square k square plus omega to the power 4 minus a4. Okay, equal to 0. Okay, very good question. Understand this, that how I'm solving it. Okay. So this became a quadratic equation, right? So we can make it a quadratic equation, right? So we can say let k square equal to u. Okay, let we put k square equal to u. In that case, it is going to be u square plus 2 omega square k, sorry, 2 omega square u, 2 omega square u plus omega to the power 4 a to the power 4 equal to 0. Okay, now what we are going to do is we are going to solve it further. Okay, so we can solve it. This is quadratic. This is in the form of quadratic equation, so we can form this using Batra formula. So this is going to be u equal to minus b. Okay, minus b, that we know, right? Minus b plus minus root b square minus 4ac upon 2a. That is the formula, right, for solving quadratic equation. So this is going to be u equal to minus b means this one. This is b, right? This one, 2 omega square, 2 omega square plus minus b square. Okay, b square is 4 2 omega square, right? 2 omega square whole square, 2 omega square whole square minus 4ac. 4a is this one, a is 1, c is this omega to the power 4 minus a to the power 4. Okay, omega to the power 4, omega to the power 4 minus a to the power 4. Okay, so this is going to upon 2a upon 2, right? So if you solve it, so this is going to be 2 2 will get cancelled, and this is 4 omega square omega to the power 4, and this is 4 omega to the power, this will get cancelled, minus minus plus a to the power 4, right? A to the power 4 means uh, a square, right? So this is going to give value u equal to two values, minus omega square plus a square. Okay, and second value is minus, this is plus, right? Plus omega square so we can write like this. We can open it, right? So this is going to be minus omega square plus a square, and second value is going to be minus omega square minus a square. Okay, so and u is k square, so k square value is going to be minus omega square plus a square comma minus omega square minus a square. Okay, and so value of k is going to be plus minus iota root omega square plus a square comma plus minus iota, because minus is there, right? Root omega square minus a square. Okay, this is the value of k, right? So these are the values of plus minus k, and this one, this is plus minus iota omega square plus a square, and plus minus iota uh, omega square minus a square, right? From here, and we can also q, that is omega, is greater than a, which is given, right? Omega is greater than a. So it means, so these are the values. So obviously from these values we can say the motion of particle is oscillatory about the orbital. Okay, implies, so oscillatory uh, about the orbital. Motion of particle is oscillatory about the orbital. Okay, so these are because of these values, right? So which option is matching? Let me check. Option C is the correct one for this. Okay, option C. Option C, right? Oscillate about the orbital. Okay, oscillatory motion about the orbital. Okay. Next question. Question number 4. Question number 4 is this is also a good question. Okay, this is fourth question, right? Fourth question is, just give me 1 second, guys. Okay. Yes, this is the fourth question. Okay, so question is the time evolution of coordinate. Sorry, my apology. So this is I will solve it this question, fourth question by trick, guys. Okay, very easy question actually, but lengthy integration. Okay, if we solve with a proper method, but there is a trick for solving this question, so you can easily solve it quickly. Okay, and this question is of 5 marks question. Okay, well, so question number 4. This is the Hamiltonian of a quantum particle. The Hamiltonian, the Hamiltonian of a quantum particle, Hamiltonian of a quantum particle of mass m, is given, that is h equal to p square upon 2m, p square upon 2m plus alpha mod x to the power r. Okay, where the value of x will be positive because this is mod x, right? Where alpha and r are positive constant. Okay, positive constants. The energy En, the energy En of the nth level, En of the nth level for large n, nth level for large n. Okay, the energy En of the nth level for large n depends on n. As, okay, options are option number A, n to the power 2r, option B is n to the power n plus 2, option C is n to the power 1 upon n plus 2. And option D is n to the power 2r upon n r plus 2. Okay, so these are the options. Okay, so I'm going to solve it by trick. Okay, I'll also tell you how you can solve it by a proper method as well, and that method is going to be very lengthy. So we can solve it within a minute by using trick. Okay, how to do it, I'll tell you. So here you can see that the Hamiltonian is given. Okay, Hamiltonian is given. That is Hamiltonian is given. H equal to H is given. This is p square upon 2m plus alpha mod x to the power r. Okay, so if we have given Hamiltonian like that, and we have to find the En. Okay, En, dependency of En on n. Okay, Okay, so for that there is a trick. So how, if Hamiltonian is like this, and if we just check x to the power something, okay, this is mod x is x to the power positive, okay. So if x to the power r, okay, if it is x to the power r or x to the power m, so in this case if x to the power r is any positive integer, okay, r is any positive integer, if the potential energy is this form, we don't just will check, we will not consider the constant, we'll just check the power of x. So power of x is positive. If the power of x is any positive constant, in that case, this is a trick, guys. Okay, in that case, the energy of nth level or any level is nth level is going to be proportional to n to the power 2r upon r plus 2. Okay, this is very important, right? Okay, n to the power 2r plus n. For example, if Hamiltonian is given p square upon 2m plus any constant beta x to the power 5, okay, positive constant. So what would be the dependency of energy n is going to be n to the power 2r, this is the positive constant, right, 2 into 5 upon r plus 2, that is 5 plus 2, so this is going to be en proportional to n to the power 10 by 5 to 7, okay, like this. So it is fixed, then we write, right. I hope you understood it, right, guys. So if there is any power of x in potential energy, and right, and there is no other term, okay, and so there would be any constant, there may be any constant, so that doesn't matter, right. If potential energy of this form beta is any constant and x to the power uh, is x to the power n, right, x to the power r, right, r is any positive constant, in that case the energy is going to be, energy is proportional to n to the power that positive constant, 2 into that positive constant, positive integer upon that positive integer plus 2, right. So for r, if it is r any positive constant, so en is going to be proportional to n to the power 2r upon n plus r. Very important formula, guys, you need to memorize it and practice questions, okay, very important question, and this is, and you will get 5 marks question, okay, and you can solve those 5 marks question in, if you know this trick, in less than 1 minute, okay. So you understand, right? If x to the power 7, if x to the power is 4, okay, if this is like this form, it is like this form, if x to the power is m, right, m is any positive constant, then energy is going to be proportional to e to the power n proportional to n to the power 2m upon m plus 2, okay. Very simple question, right. Now I'll give you the hint how you can solve this with proper method. There will be a lengthy integration, right. So we have given, so this is by trick, okay. So which option is matching, let me check. Option B is matching, 2r and plus 1, okay. Or the normal procedure, that is the proper method, I'll tell you also, I'll give you the hint. Like we have been given this, right, we have been given E equal to p square upon 2m plus 2 x to the power r, right, alpha into x to the power r. So for this we will find out, so we'll put px equal to 0, we'll found the boundary, right. Then the value of x we will find out r, right. The value of x is going to be plus minus uh, e upon alpha to the power 1 upon r, okay. These will be value of this. We'll find the value of x by putting px equal to 0, okay, in this equation. Then what the next what we are going to do is, so there is a formula, right, for finding this. So there is a formula, that is integration px dx. Okay, pdx dx is nh. Okay, for this case, for Hamiltonian particle of mass, right? This we know, this one. So from here, what we'll do, we'll find the value of px from here, from this equation. Okay, and this value, what we'll do, we'll put here. Okay, so this is going to be like this: integration px value is 2m root 2m into e minus alpha xr, okay, dx equal to nh. Okay, okay, so from like this. Okay, this one. Now what we need to do is, we need to solve this integration, guys. Very lengthy integration, right? So you can solve it. By solving this integration, you can find the value of en. Okay, this is en, guys. Okay, en. So very lengthy. So I would so you should also try also solving this question by proper method. But trick is very important, so you need to memorize it. Okay, so because in examination we have less time, right? So if you can solve these the 5 number questions in less than 1 minute, then we can score good marks. Okay, we can get good marks. Okay, guys. So well, I'm going to stop here, and also, guys, I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my live classes, which are absolutely free of charges and are going to help you to crack the examinations related to physical science. Okay, okay, guys, thank you so much. Bye now.